This is an excellent problem over here. Not much of data, and they have basically, you need to frame the data so that you can arrive at equations, right? Simultaneous equations to solve this particular problem. So what do they say? The students in a class are made to stand in complete rows. What do you mean by complete rows? Complete rows means there will be students always. For example, if I take it, right, 1, 2, 3, 4, 5. There are 5 rows like this, and there will be, say, 4 columns. Just for an example, I'm just taking it up, right? So for example, you have, say, Y columns. These are columns, right? These are columns and these are rows, right? These are your rows over here. When they say complete rows, right, you have a student standing at each position over here, all the positions over here, right? That is what they mean by complete rows. So for example, here what they have told is that they have not given the values of rows and columns over here, so you have to assume that, and they are asking you to find the total number of students in that particular class. So what are you going to do first? First and foremost thing what you need to do is that let the number of students be xy. Why did I say xy? Because I have taken the number of rows to be x and total number of columns, right, in that particular class to be y. So there are 5 benches, and there are 4 students sitting like that. Y number of students are sitting like that. Y number of students are in the total class, right? And 1 student each. 4 of them are sitting in each bench. So your total number of students will be x times y. That is what it's going to get. Okay. Now let's move ahead with what are the conditions they have given you. If one student is extra in a row, right? If one student is extra in a row, what they're saying is that they are doing away with one column. They are doing away with one column and they are basically putting another row over here. Look at it. If one student is extra in a row, sorry, it's the other way around. So what they are doing is that they are removing this row over here and they are putting the student over here. Look at it. These 4 students go in that particular row. Look at it, right? So what happens? One of the row is getting deleted. Okay, this is going off. So what will be the number of rows now? It will be x minus 1. And how many columns it's becoming? It's adding one more column. So that will become y plus 1, right? That is what it's going to happen. Okay, so no, sorry. They are saying if one student is extra in a row, there would be 2 rows lesser. Okay, they are saying that there will be 2 rows lesser, not 1. There will be 2 rows lesser. Okay, there will be 2 rows lesser and 1 additional column will come. So this should be, again, the product of these 2 should be equal to the initial number of students. It should not change. That should be equation 1, right? And the second one, when we go to the second one, now what are they saying? And if one student less in a row, right? One student less in a row, there would be 3 more rows. 3 more rows. In the next second condition, what they are saying is that the number of rows have increased and 1 student is removed from each column, right? From here, 1 student has been removed and the rows are being increased. So this is the product again. Again, this should be equal to xy. So these are 2 equations which you have got. Now you have to go ahead and solve these equations to basically find the value of x and y. So let's go ahead and do it. So when you expand this, what do you get? You get xy minus 2y plus x minus 2 is equal to xy. That is what you're going to get. When you take the product of these 2, you're going to get this is equal to xy. xy gets cancelled. So what are you left with over here? This is basically coming out to be x minus 2y is equal to 2. That is your equation number 1, right? Go ahead and solve the second equation. What do you get? You again get xy plus 3y minus x minus 3 is equal to xy. xy again gets cancelled. What are you left with over here? You are left with minus x plus 3y is equal to 3. That's your second equation. Now when you go ahead and solve those two equations, right, I can add these simple by elimination method. I have eliminated x. What do you get? You get 3y minus 2y is y is equal to 5. You get a value of y is equal to 5. Put it in one of the equations over here. Say, so x minus 2 times 5 is equal to 2. So therefore, it is equal to 10 plus 2. So x is equal to 12. So what are the number of students you are getting? What did you take the number of students to be? xy, right? When you put 12 into 5, you get the answer is equal to xy is equal to 60 students. Look at it. So now when you put these values over here, see, these are also going to satisfy. Anyhow, they have satisfied these equations, means they are going to satisfy it. So this is how you solve it, right? By putting the equations, assuming what you need to take at the start of the problem, putting the equations and creating the simultaneous equations and solving them and getting the answer this way. Good? Great. Good problem. This was a very good problem.